Starting out with just practicing evaluating on our calculators. If you see something as the following, log 327.1, and I need to evaluate it, well, because there is no base, we assume it's base 10, which means I can use my calculator. So on your calculator, type in the log of 327.1. What do we got? 327.1, 2.5, let's go to two decimal places. So 2.51, 2, how would you round that? So it's about 2.51. Okay. Don't even write this in your notes, just do it in your calculator. What would be log of 0.0615? Negative 1.21? Yeah? Did you type something in wrong? What about if I gave you an actual formula and we had to use the logarithm? So you're going to want to jot this down. This formula is also in your book. So if you get a problem in your homework that's talking about the pH of a solution, that is the formula that we're going to be using. So your pH is equal to the negative log of whatever your H3O plus, I don't even know if I'm saying that right, is. So find the pH of the water with a hydronium ion, yeah, concentration of 1.2 times 10 to the negative third power. Well, what does this look like as a number? Not in Stein. Yeah, how many zeros in front? So 1, 2, 3 means we have 2 zeros, right? So 0.0012. So now all I have to do is plug that in place of my H3O, so 0.0012. So on my calculator, I would type in the negative button first, and then the log, 0.0012. What do we get? 2.92. So that means your pH level would be 2.92. Nope. Because if you think about it, if I had a log of a fraction or a decimal, what should be the output? A negative output, right? So then if you take the negative of a negative, it would come out to be a positive. So that should make sense. So if you are inputting a decimal that's less than 1 into your logarithm for your common log, it should come out to be a negative answer. So then when you take the negative, that should become a positive. We go type it in things into the calculator for logs? Yes. Oh, yeah. That's not really that complicated, right? All right. What if we were to work backwards? So now we know the pH. Let's think about how we would do this. So now I'm going to type in 6.5 in place of my pH equals the negative log of our H3O. Oops, bracket. How would you solve for this as your variable? We can't just divide out the log, because the log's attached to this. So if it makes it easier, let's turn that into an x, so we don't have to keep rewriting H3O all over the place. We've got to solve for that for x. Put it in exponential form, right? First, let's get rid of this negative. If I make this a positive, that means the 6.5 is going to need to become a negative 6.5. equals log x. Okay, so now remember, how do I convert back and forth? If I had y equals a to the x, that goes to log base what? A y to the x, right? So we should be able to convert back and forth. So right now, we're in logarithmic form. What's the base of my log right now? 10. So now that's going to become the base of my exponent. So I'm going to have 10 to what power? Negative 6.5 is equal to what? X. Remember, X represents our H3O. Can I type that into my calculator? Sure. 10 divided by, or 10 to the negative 6.5 power. Let's put it in scientific notation. So how would I write that? 3.16 times 10 to the negative 7 would be how much hydronium ion concentration there would be. Okay? So if you have to work backwards, that's what you're going to do. So if you are given it in logarithmic form to solve for a part of the log, you have to turn it into exponential. Got that?
Is that how you write the answer? Do you have to write like that is equal to the H?
I mean, you could.
So you don't like have to though?
No, I would be fine with that. Okay. Good? Questions? All right. Let's do another formula. So this is for the loudness of sound. So the loudness of sound is measured in a unit called the decibel. To measure the sound, we first assign an intensity of I naught, or I sub 0, to a very faint sound called the threshold sound. If a particular sound has an intensity I, then the decibel level of this louder sound is as follows. So I would write that formula down. So this is your intensity of the sound. And then, or your threshold. And then what's the top one again? Or this is the threshold sound. I have that backwards, don't I? Sorry guys, move your arrow. Intensity, threshold. Threshold. All right, so it's D is equal to 10 times the log of I over I sub 0, or I naught. Sometimes that is called. That formula down. All right, so let's see this one into play. Good? So here is our example. If music delivered through the earphones of an iPod has an intensity of I of 3.162 times 10 to the positive 11th power, I sub 0, find the average decibel level. So important parts. Here's my intensity. It's be multiplied by I sub 0. Find the average decibel level. So our decibel is equal to 10 times the log. And then we're going to type in 3.162 times 10 to the 11th I sub 0 all over I sub 0, which is nice because what happens to your I sub 0s? They cancel out. So really all I'm going to be typing into my calculator is 10 times the log of, now we can't really do scientific notation, so what's that 10 to 11 going to do? Actually, I think our calculators can do scientific notation, can they? Probably.
Shouldn't you press like E or something?
Yeah, we gotta find that double E button.
It's above the 7.
Above the 7. There we go. Does everybody see it? So if we type in 10 times the log of 3.162 second, hit that comma sign, and then 11. Let's see if that works. Did that work?
Yeah.
162. So we are typing in E11. Let me make sure that actually is, yep, that's what it is. So we're getting about 115 if you round that. So 115 would be your decibel. Okay, so if you see something like that, what's nice is these probably will always cancel out, and then you're just typing in 10 times the log of whatever that number is. Okay, common logs. Go to natural logs. Do you guys remember what the natural number is?
0.
Nope, it's not. The natural number is E. Right, so you remember how pi is a symbol? And pi represents 3.14, blah, 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 blah. Well, E is the same thing as pi. It's a symbol that represents a number, which is the natural number. If you look on your calculator, underneath the log button, there's the ln button. And then in the second option, there is e to the x. If you were to hit second and the ln button and take e to the 1 power, what number do you end up getting? Yeah, so that's your natural number. And where that comes from is, it actually comes from the world of financing. If you have money in a bank account and it gains interest, they have something that's called money being compounded. So every time your account gets compounded, it earns interest. And back in the day, your money would sit there for a whole year, and at the end of the year, they would add in the interest. And then they started doing it biannually, so every half a year, interest was being added on, and then they did it quarterly, and then monthly, and then daily. And if you keep working through making the compoundings happening more often, they all start hovering around this 2.71828 number, which is kind of cool. So E, we just want to write that down. E is equivalent to 2.718, let's say, or 2.72. Do you need to memorize that? No, because your calculator can easily tell it to you what it is. But when we start talking about a natural logarithm, the base of the log ends up being E. Just like the common log, the base is 10. In a natural log, your base is E. And another way that we then write it is we use the letters ln. I don't know why it's not NL for natural log, probably because it looks better with an L first. So we use ln for natural log. I don't know, I'm making that up. Okay, so instead of writing log base E, we write ln. It's just a nicer way to make it look, I guess. So whenever you see a log with no base, we assume the base is 10. Whenever you see an ln, we're talking about a natural logarithm, which has a base of E. So whenever you see that ln, you should be thinking the base of this logarithm is E. What is E? E is something equivalent to 2.72. Okay? All right. So I wouldn't even put this in your notes. We already talked about that. Can you type that into your calculator? The natural log of 0.5841. And we get negative 0.538. Yeah? Which makes sense, because my decimal after the log is a number less than 1, so it should come out to be a negative, right? Okay? Yeah, the ln. Can you type in the ln of 192.7? What do we get? 5.26. So that means if I were to take E to the 5.26 power, I should get something close to 192.7. right? Let me quickly write that so we can think about that backwards. So this is about 5.26. So that means if I were to convert it from logarithmic to exponential, e to the 5.26 power should end up being something close to 192.7.
192.5.
Okay, so yeah, our rounding throws it off a little bit, but it's pretty close. Okay? If I wanted to evaluate e to the 5.26 power, I would hit second in the natural log button, and then 5.26, and it would get me 192.5 like Jenna said. So we're off a little bit. All right, we can type in natural logs into our calculators. All right, so now let's use it in an actual function and apply it. I would just write this equation or function down. The altitude in meters that correspond to an atmospheric pressure of x millibars is given by the logarithmic function defined by f of x is equal to 51,600 minus 7,457 natural logs of x. We want to use this function to find the altitude. So find the altitude when the pressure is 400 millibars. So where's that going to go in place of? X or for f of x? It's going to go in place of x, because x represents x millibars. So all we're going to do is some fancy button pushing. So 51600 minus 7457 times the natural log of 400. See what that gets us. 457 natural log 400. I'm getting 6,921.65. And we're in altitude, so that's meters. All right, so nothing too crazy yet, right? Okay, so now can we jump to this problem right here? Well, not that specific one. We need to figure out how to evaluate log base 6 of 10, either using the common log or the natural log, using something that's called the change of base formula. So this might be the trickiest thing for the day. Maybe. Yes?
I found how to do it in calculator.
Where it just gives you the blanks? Yeah. All right, is everybody good?
No.
Oops. I'm back. I know, I'm gonna have to I'm gonna have to take this scarf off. I'm sweating. Okay. All right, so here is your change of base formula. You can use the change of base formula, or rule, whatever you want to call it, to change any logarithm of any base to a quotient of two similar bases. So if we have log base a of x, log base 6 of 10, what we can do is we can convert it to two logs that end up having the same base, and we put the x attached to the log in the numerator, and we take the a and attach it to the log in the denominator. What I like to think of is that the a goes in the basement. That's how I always remember it. Because it's the base, so the base goes in the basement. Got it? So now, usually, since we have two buttons on our calculator that we can use to evaluate logarithms, we are either going to make our b be 10, or we're going to make that b be an e. Because if I make my base of both of these a 10, then I could just use the log button on my calculator. If I make both of these have a base of e, then I can just use the ln button on my calculator. It doesn't matter which one you use. It's going to come out to be the same answer no matter what. So that's just a decision you need to make. Okay? All right, so let's go ahead and do some change of bases. And that's all we have for today. So, log base 5 of 12. We're going to first use common logs to change it, and then we're going to use natural logs. So let's think quickly in our head. Do I know what 5 to what power is 12? No. It's going to be in between what two numbers? 1 and 2, right? Because 5 to the first is 5, 5 to the second is 25. So it's got to be somewhere between 1 and 2. So now we're going to use common logs for our change of base. So what I can do is I can rewrite log base 5 of 12 is equal to log of 12 divided by log of 5. The base goes in the basement. Then on my calculator, I can type in the log of 12, make sure you close that parenthesis, that gets attached to the 12, divided by the log of 5, and we get about 1.54. Make sure you close the parenthesis after the 12, because if you don't, then it's going to take the log of 12 divided by the log of 5. Now let's do the same thing using natural logs to show that you get the same answer. So if I did log base 5 of 12 and did the ln of 12 divided by the ln of 5, do we get the same number?
She got like 0.7s. I mean, she's in like different like degree of.
No, that shouldn't make a difference. Do we get the same thing when we use the ln button? Yeah, there's no division going on there. You're multiplying. You gotta put a fraction bar. It's right below the log.
Oh, okay.
You need to actually divide it. Okay? So now, it was just using ln instead of the log button. Last thing, got an equation where we're going to have to work backwards. All right, so here we go. We've got the function f of x equals 38.33 plus 4.208 log base 2 of x. This is used to find the percent of women who return to work after having a baby in 1995. X equals 0 represents 1980. All right, so if 0 represents 1980, how many years is it from 1980 to 1995? 15. So that means we're going to make our x equal 15. So that means I'm going to substitute 15 in place of my x. So we have the function f of x equals 38.33 plus 4.208 times the log base 2 of 15. I don't know what log base 2 of 15 is, but luckily we can do that by using the change of base. So either in your calculator, type in log base 15 divided by log 2, or sorry, log 15 divided by log 2, or type in ln 15 divided by ln 2, and let's turn this into an actual number. So log 15 divided by log 2, 3.91. Let's multiply that by 4.208. So this whole entire thing becomes 16.44. Is that what you guys are getting? Add that to 38.33. And we get 54.77. Is this in millions? No. Oh, it's percent. So 54.77% of women return to work after having a baby in 1995. Okay? Any questions on any of this stuff? It's pretty easy, right?